So Ax equal to lambda x. So the vector x in this case is just changing its magnitude, and it doesn't change the direction. So this vector x is called as the eigenvector, and the amplitude or the magnitude is changing by some units, and lambda represents the change in the magnitude. That lambda is called as the eigenvector. Now our task here is to find eigenvalue and eigen. So what do we do here? So we have Ax equal to lambda x. Anyone wants to say something? Fine. So we need to find the eigenvalues and eigenvectors. So what we do is we solve this system. So what we have Ax equal to lambda x here. So once we have Ax equal to lambda x, what I can do is Ax minus lambda times x equal to 0. Okay. So we need to solve this equation Ax equal to lambda x, and if I am able to get the value of lambda or the value of x, then we are done. So I'll take x common, a minus lambda times x equal to 0. Is this well defined, a minus lambda? Is it well defined, a minus lambda? I want the answer fast. It is quite simple. I mean, it's not so difficult that you need to think so much. Alok? Alok Bajoria, roll number 15. Now he will not respond. Giving the vote twice to the same candidates, he is very much active in that. Okay, so A is a matrix here, and lambda is a number. As I said, lambda is the value by which the vector changes its magnitude. So this is a number, and this is a matrix. So the subtraction is not defined here. So what we do is, in order to make it possible, what we do is we multiply that lambda by I. So what we have is A minus lambda I times x equal to 0. Now my question is, what will happen if determinant of A minus lambda I is not equal to 0? Then what will happen?
X equals 0.
Why x equals 0? How can you say that x will be directly 0?
Because A minus lambda I is not 0.
It's a matrix. It's not a number. Mohit, Manan. Look, if you don't respond, I'll start removing you from the meeting. Considering.
I'm thinking. So.
Khushi. Tanaya. Sania. Alan.
I don't know, sir.
You people don't know what happens if the determinant is not equal to 0 to a matrix. Have you really passed 12th standard? Not a single person knows that what happens to a matrix if determinant is not equal to 0.
Sir, it is invertible.
It is not
It
invertible.
is?
Not invertible.
Acha, it is not invertible. If the determinant of a matrix is not equal to 0, then the matrix is invertible. So that's the inverse of the matrix exists. Okay. And so now A minus lambda I inverse exists. And once it exists, what I can do is I can multiply by the inverse on both the side, and what I will get is x is equal to A minus lambda I inverse of 0. So which gives me x equal to 0. Just a minute. So x will turn out to be 0. But in the definition of eigenvector, we saw that what we want is non-zero vectors. Okay. So eigenvector should be non-zero. We should get non-zero values, non-zero vectors. Okay. So to have this condition hold, what we should do? So to want, in order to get non-zero eigenvector. What condition should be given? What condition should be given on this equation? No condition should be given, is it? Mrunmay?
Yes, sir, thinking.
Ishan. Yes, Parth, tell me.
There will it be the determinant of A minus lambda I is equal to 0?
Yes, exactly. Very good. So, in order to get this non-zero eigenvectors, what we do is we consider A minus lambda I to be 0. Okay, so this equation is a very important equation which is called the characteristic equation. Characteristic equation, which is also called the characteristic polynomial. Characteristic polynomial. Look, the word itself says that you are going to get a polynomial. Okay, so I will consider that suppose if I get a3 lambda cube minus a2 lambda square plus a1 lambda minus or plus a naught equal to 0. बोला. So, can someone tell me what could be the next step? If you solve this polynomial, what you are going to get? Solving yes, what we will get?
Three solutions.
Which solution you will get? What values you are going to get after solving it?
Numbers. 3 values
Wow.
of lambda.
So, what is lambda?
Eigenvalue.
Eigenvalue.
So, solving this polynomial, we will get eigenvalues. So, solving, we get eigenvalues. So, half of the problem is solved now. What is the half of the problem? So, we have the matrix A given. What we need to find is eigenvalues and eigenvectors. So, we can write down the characteristic polynomial. We'll solve the characteristic polynomial, we'll get the eigenvalues. Now, to find eigenvectors, how will you find eigenvectors? Say if you got lambda 1, lambda 2, and lambda 3 as the 3 eigenvalues. So, how will you find eigenvector?
We can put the lambda, each lambda in the equation. मतलब वो matrix A minus lambda I equal to 0. Characteristic equation.
A minus lambda. This one?
Yes.
Yes, Rameshwar, which one? Yes. This one.
Yes.
How will you
Yes.
get x from this? What is eigenvector? We need to find x. There is no x in this equation.
Oh, sorry. Sorry, sir.
Which equation?
So the previous one, so A minus lambda I whole multiplied x is equal to 0. Yes, sir.
Very good. So what we will do is, now suppose if I got the eigenvalue lambda 1. So corresponding to this eigenvalue, I need the eigenvector. So what I will do is, I'll put this here, a minus lambda 1 times I into x equal to 0. So we will solve this. Solving, we get eigenvector corresponding to lambda 1. Similarly, what I will do is, I'll put lambda 2 there. I'll take a minus lambda 2 times I into x is equal to 0. Solving that, we'll get eigenvector corresponding to lambda 2. And similarly, the third one. How many solutions we should get here? There will be one
3.
solution. Simply x equal to 0. Is it possible? Yes, I'm talking particularly about lambda 1. When I put lambda 1 there, a minus lambda 1 into I bracket matrix complete x equal to 0. So I'm saying that I'll solve this to find out x. Is it possible that I'll get simply x equal to 0 only?
No, sir.
No.
So how many you should get? Note that it is a homogeneous system. This is a homogeneous system. So I'll call this a minus lambda 1 I as b. B into x equal to 0. If it cannot have a unique solution, how many solutions it must have?
Infinite.
Infinite. So we are going to have infinitely many eigenvectors for a respective eigenvalue. Now this is the complete process. Let's just recall what is the process. So you will be given a matrix A. You need to find eigenvalue of eigenvector. What will be the first step that you do? Everything is on your screen. You just need to sum up in 3 statements. First step, what will you do?
Sir, we'll form a characteristic equation.
Very good. Once we get the characteristic equation, what we will do?
Find
We'll
lambda.
solve.
Find lambda. We'll find the roots. Next.
So next find eigenvector
Substitute
with
them
the
in
formula.
Yes, exactly, Rameshwar. So what we will do is, for each eigenvalue, we'll find the eigenvectors by substituting those in this equation. Now the only thing remains is, so I'll go to the next page. So how to write down the characteristic equation. Okay, so this is the method. What is the method? Write the characteristic polynomial for A, which is a minus lambda I equal to 0. Roots of the characteristic polynomial, say lambda 1, lambda 2, lambda 3. For each eigenvalue of lambda I, we find the eigenvector by solving the system of linear equation a minus lambda I times x equal to 0. There is a brain teaser given. I know I will waste the time if I discuss it right now. You just think over it and let me know. So the question is, can the same eigenvector correspond to two different eigenvalues? If no, why? If yes, can you find it? So the question is how to talk about. This is all what I have written on the whiteboard. So this is an important one. So there is a shortcut method. I mean, by shortcut method, you can directly write down the characteristic equation. You don't need to, we know that our characteristic equation or the characteristic polynomial is this: determinant of a minus lambda I equal to 0. Now there is this shortcut method by which we can directly write down the characteristic polynomial for a 2 by 2 matrix like this. So a11, a12, a21, and a22. This is my matrix. And for that 2 by 2 matrix, how can I write down the characteristic polynomial? The characteristic polynomial is this. It is lambda square minus s1 lambda plus determinant of a equal to 0. What is s1? Sum of diagonal diagonal entries. Actually, diagonal matrix, this is the wrong statement here, but it has to be sum of diagonal elements. Sum of diagonal elements is nothing but the trace of the matrix. So lambda square minus trace of the matrix into lambda plus determinant of a equal to 0. Now what happens for the 3 by 3 matrix? This is the 3 by 3 matrix here. The formula is this: lambda cube minus s1 lambda square plus s2 lambda minus determinant of a equal to 0. What is s1? S1 is again the trace of the matrix. What is S2? Sum of minors of order 2 of diagonal elements. So you look at the diagonal element A11. What is the minor of this? Minor of this. So if I take A11, the minor of this is going to be this matrix 2 by 2. Right?
Yes,
So you
sir.
can see that the first one is this. Now I will take A22. If I take A22, then the minor of A22 is A11, A13, A31, and A33. So you can see that the second one is this. Similarly, at the end, what I will do is I'll take the minor of the A33. If I take the minor of A33, what I will get is this 2 by 2. So you can see that the last one is this. So for a 3 by 3 matrix, lambda cube minus trace of A into lambda square plus the sum of minors of diagonal elements into lambda minus the determinant of A equal to 0. So these are the two rules. If you have a matrix which is not of the order 2 by 2 or 3 by 3, what we will do is we will take this equation and we will write down the characteristic polynomial. I hope everything is clear now. If you have any difficulties, ask, or I'll solve an example on this. Yes. So find eigenvalue and eigenvector. Find eigenvalue, values, and eigenvectors for A is equal to, let's start with the small matrix. -1, 0, 0, 1. First step. First step.
The characteristic equation a minus lambda I equals to 0.
Characteristic polynomial. determinant of A minus lambda I equal to 0. This is a 2 by 2 matrix. Use the shortcut method. What is the characteristic polynomial? Lambda square minus
A
S1
into
lambda.
Lambda plus determinant A equals 0.
S1 into lambda.
S1 into lambda plus determinant of A equal to 0.
Determinant of A.
What is S1? S1 is equal to
0.
trace of A, and it is minus 1 plus 1 0. So our characteristic polynomial and the determinant of A is minus 1, right? So what we'll get, lambda square minus 1 equal to 0. So lambda square minus 1 equal to 0. So lambda plus 1 into lambda minus 1 equal to 0. So what we have, lambda equal to 1 comma minus 1. So the eigenvalues are eigenvalues are 1 comma minus 1. Next step is
Eigenvector.
eigenvector corresponding to each eigenvalue.
Yeah.
So eigenvector vectors for lambda equal to 1. What we have to do?
A lambda 1, A minus
is equal to 0.
lambda
A
1 I.
minus lambda 1 is 1 times identity into x equal to 0. This is what we need to solve. So what is it? Minus 1, 0, 0, 1. Minus 1 into identity matrix 1, 0, 0, 1 into x equal to 0. So what is this? This is going to be minus 1, which will be minus 2, 0, 0, 0 into x equal to 0. Let's rewrite the equation. Say I'll consider x as x comma y. So this will be minus 2x equal to 0. What is the eigenvector? How many solutions you have here? Let's just talk in detail. So what I'll write is the augmented matrix minus 2, 0, 0, 0. This is 0, 0. What is the rank of A? Rank of A is
1.
1, which is equal to rank of augmented matrix. How many variables you have? How does the x look like? X कहाँ का vector है? X and y. There are two variables, right? Which is
Yes.
less than the number of variables. So minus 2x equal to 0. Which variable is free? Tell me fast.
Y.
No, y is free variable. So we'll consider let y is equal to t. And minus 2x equal to 0 gives me x equal to 0. Right? Hence, eigenvectors are zero t. And t belongs to the set of real numbers. Corresponding to lambda equal to 1. Any difficulty? Clear to everyone? Kuldeep, is it clear?
Yes, sir.
Yes. Can you find out the eigenvector for lambda equal to -1 then? Eigenvectors for lambda equal to -1. Do it fast. Be quick and tell me the answer. I need the final vector.
T0.
What is the answer?
T0.
T0, exactly. T0. Graphically, can you tell me what is this? 0t and T0.
X and Y axis.
Exactly. So 0 comma t, this is y axis and this is x axis. So what conclusion you can make about this matrix after the transformation? What this matrix does?
It shows the position of the vector.
It
Gives the position of the vector.
position of the vector. No. I mean to ask is you will do the transformation. Every vector on a plane will be transformed when you multiply this matrix to every vector on the plane. And now, after the transformation, you have got eigenvector. So y-axis, all the vectors on y-axis are the eigenvectors corresponding to lambda equal to 1. and all the vectors on x-axis are corresponding to the eigenvalue lambda equal to -1. So I want you to summarize everything and tell me what is happening after the transformation.
So we get xy plane coordinate axis.
You're not thinking in terms of eigenvalues and eigenvectors.
Means for different value of t, we get different value in x and y axis. So it gives the altogether data in the xy plane like that.
No. Okay. Before going to that, let's go step by step. Can you tell me what is happening or to the vectors on x-axis after the transformation? Look, linear algebra is so much important that you choose any of the field. You go for machine learning, or you go for data science, or you go for artificial intelligence. Everywhere you will need this eigenvalues and eigenvectors. That's why I'm spending so much time just discussing with you. Please tell me what is happening. Okay, can you give me one vector corresponding to eigenvalue lambda equal to 1? Give me a particular vector.
J cat.
Yes? One vector I want.
So
0,
0,
1.
1.
0, 1. Okay. If I want to verify whether this is correct or not, what can I do?
Substitute it in A minus lambda.
A minus lambda. Anything else? What is the basic definition of eigenvector? Basic definition of eigenvector is all the vectors of the form, all the vectors which satisfy the equation Ax equal to lambda x, right? So what you do is you do the multiplication. -1, 0, 0, 1. If you multiply this to 0, 1, what you will get? 0, 1. Did you get 1 into 0, 1? So this equation is satisfied. You can see A into x is equal to this value is lambda into x. Okay, so this is the way we can actually check. What happened here to the vector 0, 1 after the transformation? Ax equal to 1 into x. What happened to the vector 0, 1 in this case? Is there any change in the vector?
No.
No. There is no change of magnitude. There is no change. The vector remains same. So can I say that after the transformation, the vector lies, I mean, it is the same. It doesn't change the direction, nor does it change the vector. So what happens to the vector on y-axis? What happens to vectors on y-axis after the transformation?
Constant.
Think over it. Take a minute, then answer. Take your time, think. No one can answer.
It changes the direction, but magnitude remains the same.
Yes, please repeat and then listen.
It changes the direction,
Direction,
and magnitude remains the same.
magnitude remains the same, exactly. The direction, can I say that an eigenvector remains on the same line? I mean, the line is same. The vector 0, 1. But what is actually happening graphically by this matrix? Can I say that it is a reflection? So
Yes.
Yes.
whatever vector say, I will have say, take a vector on x-axis for an example 0, 1, 1, 0, sorry. This vector 1, 0. After the transformation, what you are going to get?
-1, 0.
-1, 0. So what happened? The reflection about y-axis. So the what's happening is the reflection. And in this reflection, the vectors on y-axis will remain same. There won't be any reflection, right? And when we talk about the vectors on x-axis, they will, if they are in this, then they will come on this. So they remain on the same line, but it doesn't change the magnitude. So this is what is happening in this case. So in next lecture, I'll solve some more examples for eigenvalues and eigenvectors. Any difficult